So we've studied slope-intercept form. That's helpful because then we can quickly see what the slope is of a line. So if you were to graph these two lines, the first one has a y-intercept of 4, so it crosses at 4, and then it goes up 2 to the right 1, up 2 to the right 1. If you graph this one, it's got a y-intercept of 0, right? It goes up 2 to the right 1, up 2 to the right 1. Now, if you were to make these lines, and I can't draw with this mouse. Okay, there we go. That's pretty good. They never cross, right? They're going up and to the right at the same pace as their brother or sister line over here. So since they never cross, we say that these two lines are parallel. And then we also have something that we identify as perpendicular if they cross and make a 90-degree angle. So it's almost like they're going in perfectly opposite directions. Okay, so these two lines are perpendicular. We said parallel lines, they have the slope. The slopes are equal. So m are equal. So perpendicular lines, one slope has a slope of m and the other one has a slope of -1 over m. Or in other words, to find out a perpendicular slope, flip the slope and then change the sign. So let's say we have this equation. To figure out the perpendicular slope, it's going to be -3 over 2. I flip the fraction and I change the sign. Or let's use the equation we have up there to find a perpendicular slope. Right now the slope is 2, or in other words it's 2 over 1, right? So the perpendicular slope would be -1 over 2. Flip the fraction and change the sign. Okay, so let's do one last example of that. You're going to have questions where they ask you to look at the equations and tell us, we need to tell them whether they're parallel, perpendicular, or neither. Alright, that's a 2. Looks kind of like a Z. But let's see, so we got that one. We got this one here. So we don't know what the slopes are just by looking at them. But if you do what we've done before, you do the algebra work to get y by itself. This equation you should get y is, let's see, 1/2 x minus 2. Let me just double check that. Subtract 2x. 5 by -4. Yeah, and then this equation, if you do the work to get y by itself, you subtract that 6x from both sides, then you divide everything by -3, you're going to get 2x subtracted by 3. Yeah. Okay. And so when we look at, now we can just look at the slopes to decide whether they're parallel or perpendicular, or in this case, neither, right? That's almost perpendicular, but the signs are the same. For them to be perpendicular, the signs have to be opposite.